Once you've built your plane, the next step is to go outside with your teammate or teammates and start flying the plane. Look on the ground for one of these little dots. These are the places from which you can throw from. Just find an open dot that's not near other people so you don't accidentally wreck their planes or have them wreck your planes. So I have the dot on the floor, and one of the jobs is going to be the thrower. Right now I'm going to be the thrower. The other job is going to be the observer. The observer should stand in the direction where you think you're going to throw the plane, just to keep an eye on the plane and make sure somebody doesn't step on it. So I throw the plane, and at first, you're going to throw it, each of you should throw it a few times. Just get an idea of what's the best way to throw it. Should you hold it in the front, back, under the wings? I usually like over the wings and throwing it straight, but sometimes it's better to throw it down a little, sometimes it's better to throw it up a little. Just try it out and see what's the best way to throw the plane. Once you figure out the best way to throw the plane, now you're ready to start your experimenting. Throw the plane. Now, I threw the plane and I'm going to measure. We're going to measure taking steps, taking footsteps. Heel to toe, heel to toe footsteps. 1, 2, 3, 4. My plane went 4 steps. In my data table, I'm going to write distance for E. 4E for 4 Eric steps. Now, what were my observations? My observation was the plane went straight down. So I wrote down the plane went straight down. We're going to fly it a few more times, and let's say the same thing happened all 3 times. Let's say it went down all 3 times. Now I need to think about the forces that I learned about with a plane. Gravity, lift, friction, thrust, and direction. Direction means your plane's not going straight, so maybe if it's going right, you got to figure out a way to make it go left. So if my plane kept going down, 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 what force should I work on? Well, gravity's going to make it go down more. What about lift? Lift. So I'm going to write here for my next flight, I'm going to work on. I want the lift to increase, so I wrote a lift with an up arrow. I want my lift to increase. So what do I need to change to make the lift go up? What are the ways we can change the plane, or in this case, what are the ways we can increase lift? I recall from the videos that when the wings are curved, the air gets pushed down, which means the plane goes up. So I'm going to work on curving the wings because I hope it will get more lift. I'll go into the art room with my teammates. We'll work on curving the wings. We'll come back outside. We'll take a few throws. We'll measure it, and we'll say what happened. Then we'll figure out, do we want to give it even more lift? If so, we'll do something else to give it more lift. If we want to give it more weight, we'll say we need to work on gravity. So we'll make a change to gravity. So let's. Perhaps the most important force on an airplane is lift. Lift makes the plane go up. And you've seen some videos, and you can still watch videos on the different ways that a plane gets lift. The main idea is that when the plane is pushing the air down, the air pushes the plane up. And the main way the plane pushes the air down is by curving the wings. The curved wings lead the air to be pushed down, and the air pushes the plane back up. So, how do you get the wings curved? Well, there's a lot of different ways to get the wings curved, and you're going to experiment with different things. You're going to have lots of pieces of different size cardboard or hard paper, and you're going to try to figure out ways that you can curve the cardboard and then attach it to the wing. Maybe you want to start off with a small piece and see if that affects how high the plane can go. Maybe you want to start off with a larger piece. Small pieces are usually easier to attach to your wings. Large pieces are usually more difficult. The other way you can affect the lift is by the elevators or the back of the plane. Making the back of the wing more curved sends the air down, which pushes the back up and sends the plane down, or putting the elevator up sends the air up, and when the air goes up, the elevator goes down and the plane goes up. So when the elevator is up, the plane will go up. When the elevator is down, the plane will go down. Let's say I want to give it even more lift. I could curve the wings some more. I could put the elevators up. So I put the elevators up because I want to give it more lift. And then I'll fly the plane, see how far it went and see what happens. If it's going too high up, that means I need to give it more gravity. What could we use for gravity? What could we use for gravity? One of the ways we can reduce lift is by adding weight. We reduce the force of lift by increasing the force of gravity. And one of the tools you'll have at your disposal are screws. Remember, screws are meant to be turned. So if the nose of my plane is going up, maybe I want to add some weight so that gravity will give the nose of the plane less lift. Notice I'm turning the screw into the plane. By turning the screw into the plane, one, the screw stays in, so it won't fall out and somebody won't step on it. And two, if I realize that I really didn't want to put that weight in the front of the plane, then I can unscrew it and put my screw away. Screws are one of the ways that you'll be able to add weight. We could put one screw. I could screw in the nose and then see how it works. So this is how you fill out your data sheet. You should fill it out after each flight and then before you make changes to do your next flights. Make sure you're using your data sheet. Sometimes when we share documents on the iPads, we might have gotten the document from someone else's group, so make sure it's the one that has your name or at least your teammate's name on it. Don't use someone else's data sheet.